All right, I'm gonna go ahead and get started. Who wants to see a demo? Yeah? Cool, so the demo I'm gonna try to show you is kind of the bare bones of building an IDP in the now less than 25 minutes I have. So difficult, but I think I can do it. I'll try. And I want you to steal this IDP. I want you to take it and use it and make it your own. Because of the problems, the issues that we run into with this approach, if I were to just stand up here and regurgitate those and not provide something, give you something that's a path towards a solution, well, then I'm kind of part of the problem. So to me, I do not care if you run this on our cloud or your own cloud or anyone else. What matters to me is this community, peer-to-peer, help each other out. And when I speak about IDP, I am specifically talking about internal developer platforms, the whole platform engineering jingle, which is a little bit icy hot, right? Because what is it, some 67% they're saying of platform teams are failing at the initiative. And then to push back against that, you have Gartner pushing this number that 80% of organizations are going to adopt platform engineering by 2026. So these two numbers, they don't really complement each other, and if that's true, well, we are in for some toil. Toil. If you're a developer, you're in the best place you can be. Everyone's racing each other to remove your toil. But at a 67% error rate, is it really getting removed, or is it sort of just getting repackaged and moved from here to over here? And there are many reasons why that is, and many of them true. But one that I think gets overlooked a lot is that although we are very good at being dry, don't repeat yourself, and we really are, right? We're DevOps people, we live for this. But we're not so good at being drrrr, or however you would pronounce that, which is short for don't reinvent the wheel. And we do this all the time. I mean, we love reinventing wheels. I love reinventing wheels. It's fun. This is our baby, don't call it ugly. But we have to be honest sometimes that it does bite back in some situations, like, I don't know, scale. And so the proposal here is, or the approach I want to show is the drrrr approach towards an IDP, because even with the golden path templates that we agree are the better practice, how much are we reinventing the wheel of the process of creating those templates? So the idea here is more, if you can think of one golden path template for the IDP itself, you can build onto from there. The motivations, open source. The app platform that I'm going to show is about 95% just CM/CF projects. The little 5%, that sliver of custom code, is also open source, Apache 2 license. It's just there to glue some things together. And that makes this cloud agnostic. And if you don't think that cloud agnosticism is important, it is my very strong opinion that you should, because portability matters. And then dog fooding. It's one thing for me to come up and pitch something at you, but it's something more if I'm like, oh yeah, and I'm doing this myself. So that's actually where this talk comes from, is I was working with our marketplace team. They do all the back-end development for the one-click apps and one-click clusters in our cloud marketplace. And the team needed this sort of developer portal experience. So it was a perfect opportunity for us to eat our own dog food. But where the fun cuts in is that the core dev team behind this, their efforts and all their focus right now are entirely on the UI experience. And that isn't how our team works. We do everything as code, everything. So what that means is I've had this fun little project to be the only person doing that with this app platform, which is, again, is this sort of IDP golden template framework. So what I'm going to show you is basically I made a fork off one of our iterations of this internal project and made it more basic and so on. It is heavily still in the prototyping phase. So it is all subject to change, but as the actual project structures and matures, I will port some more things over to this example one because I want to share. So I encourage you to follow it if you're interested. The tech stack, Kubernetes. For infrastructure as code, we're using Pulumi and also using Pulumi for external secrets management. That's because I found there to be more flexibility with it, and using the secrets manager in addition, smooth. The app platform is the Helm chart that, well, installs the platform, and then it installs a bunch of subcharts and does a bunch of other magic. I am going to be speaking really quickly because I'm trying to fit in my time window here. So just so you know what I'm talking about, anytime I say LKE, I'm just talking about my Kubernetes cluster. I'm using the Linode Kubernetes engine for this example, but it could be any other. APL is short for app platform, and if you hear me say OBJ, I'm talking about object storage. So what we did was we just took that nebula that's easy to get lost in of the CNCF landscape and just narrowed it down to an opinionated set of these apps that are just the fundamental pillars of a production-ready environment, from developer tools, functions, observability, security, and so on. And with that, let's check out the demo. And unfortunately, due to time constraints, I can't show you the Pulumi portion of this, but I really like that part, so if you want to come hang out with me afterwards, please do. But this first part, this is actually just the template for the values YAML file for the Helm chart. I'm going to make the assumption that everyone here knows what Helm is and the purpose of the values YAML, so I'm not going to discuss that. But I'm showing you this to demonstrate we're talking about basically just deploying a platform. So what this provides is an opportunity to design and paint and fully furnish your home before you ever move in. And so the most important, you remember the last slide with those CNCF apps I showed you. Here's just where we're defining which ones I'm going to turn on by default, because they are not all on to begin with, as they shouldn't be, because you should always start simple and add on as you need. So I'm only turning on, in this example, the ones that I think this marketplace team is going to use right away. So they have Alert Manager and Grafana enabled. I gave Argo CD some more resources because we're going to be putting a heavier load on it than its default. The Ingress controller has an annotation for a static load balancer provisioned by a Kubernetes provider, and I'll talk a little bit more about that later. Harbor, Knative, the rest of the observability stack. The team likes to use RabbitMQ to return that one on, and then Valero for snapshot backups. The platform comes with end-to-end GitOps configured right out the box. No further action on your part, but that means we need to give it a key management SOPs provider so that it encrypts your sensitive values before it writes to the repos. We picked Age as the provider. You could use AWS KMS or HashiCorp Vault or any of the others, but Age is very lightweight and the most platform agnostic. As some object storage buckets are created to be the backends for some of these apps. You create some schedules and retention policies for backups for just some of the core databases that are the beating heart of this platform. But the bigger thing I want to show here is this part of the team config. Because the team's experience is huge. That's kind of one of the biggest components of the whole IDP thing. And there is actually so much we can do with this. We can make it so that we can define right here, they can have deployments and services, custom repositories, their own Knative functions, containers, actually already there before they even log in the first time. So there's so much we can do with this. Of course, I simplified it for this demo. Created one team called Develop. They have some self-service capability to create services and use their shell and download their RBAC to kubeconfig, but I'm restricting them from editing security policies and the Docker login. I flipped on manage monitoring for them, as I should. It's namespace to their workloads, some basic network policy, and resource quotas of 50 pods and 10 service load balancers. And now we will deploy this with Pulumi. So this is actually leveraging the Pulumi automation API, which the way I have it structured now is, again, prototyping. So there's actually one monolithic stack, and at some point we will want to chop this into smaller micro stacks that we version independently. And so doing it this way in these multi-stages just kind of gives like an early idea or model of where we might want to do that. But it's also because there's more than one provider at play here. There's the Linode provider provisioning our cloud resources, and then we have a Kubernetes provider doing the Kubernetes native way of provisioning a load balancer. So from an infrastructure as code point of view, and you have two providers in resource state and getting them to talk, is more code than I felt like writing. Simply, it's easier to do it this way, and that's fine. The drawback being that it means you sort of would have to, and you've probably done this with Terraform before, where you have different providers and you have to run the apply and then just run it a second time to pick up some of those resources. So this is doing that same thing, but the automation API is just, well, automating, running this 4 different times, so it's all one fluid motion for us. So that's what's happening here. It's creating the object storage buckets, and it created our LKE cluster. We can see those are the object storage buckets and our Kubernetes cluster. Okay. If you go back to Pulumi, on this stage is finishing setting up the static service load balancer and our DNS. So we should see our load balancer resource pop up there. And it's connected to the cluster. And all the same, should have a DNS. Yep. And as long as Pulumi continues doing the wonderful things that it does, shortly after it populates our DNS records. So, and then this phase of it, this is, you see 3 of 4, this is purely just a wait for DNS phase, because we want to make sure that the auth and keycloak subdomains resolves to the load balancer IP address before we provision the app platform. And then, of course, the final step of actually provisioning the app platform. Now, in reality, this is a really beefy Helm chart, so it actually takes somewhere between 10 and 20 minutes to go do all this. So from Pulumi's point of view, its work is done here, and I'd rather leave it that way than like add some time out and the wait for jobs and so on. Because if we want to follow what's going on, we can just watch the logs for the job, the APL job running in the default namespace, and watch it in real time. And when it finishes, I get this little message of the day that has some kubectl commands that we just copy and paste to get the default username and password for the default platform admin user. So we'll go ahead and get that and get the password. And copy that over. And paste it in. Keycloak is going to force us to update the password on the very first login. And this is your platform. This, I guess from a UI perspective, looks like a cloud provider's console. There's some sort of SaaS, but it's not. This is just you running this in your own Kubernetes cluster, and you have total control over it from this point forward. So the first thing we're going to do, and this will be more automatable sometime in the near future, but we do need to connect the object storage. These parameters are filled out already because of the Pulumi code that I wasn't able to show. Click submit, and this is interesting. This little pop-up up here. See what that is about. A Tecton pipeline with a git commit hash. Let's check that out. That brings us to a self-hosted git key. We can log in with OpenID through Keycloak. And we have our initial platform admin repos. We go to values, and there that top commit. And then here's the diff for what we just merged to connect our object storage buckets for Loki, Temple, Harbor, Thanos, and Cloud Native PG. So GitOps, out the box. Every user interaction triggers a pipeline to write this to Git. So we can roll back, can roll forward. And then you remember in that values file, these were the apps that I enabled for this by default, for this iteration of this platform and this team. The ones that are grayed out there are the ones that I left out for now. And if we want to turn one on, because, okay, we probably need Thanos, I can now add that to my golden path template for this for the next deployment. But for this one that's already running, just click that button. Again, triggers a pipeline because it's GitOps. And we now have that. So next I want to show you is the team view experience. So if we switch over to that, this is what it would look like if you logged in as a member of the develop team that we created. You can see we have completely different dashboards. It's just for our space. And you'll notice that the options on the left-hand panel have changed as well. Minus, we still have an apps, and these are just ones that are turned on for them by default, and we can change that. But then we have this cool little thing here, a catalog. You know, and with the whole platform engineering thing, we love catalogs because they're extendable. These are quick start Helm charts, deployments that any of these teams can just fire away. And now these other options here on the panel, I'm not going to go too deep into every single one of these, but if we look through this real quick, we have code repositories. They can add their own custom code repositories, container images, or build packs, team-spaced sealed secrets, workloads, which would, in Kubernetes speak, translate to deployments, network and security policies, and services, and so on. So this is that developer experience. This is that portal they can just log into and do what they do best and write us cloud-native applications. And with their own monitoring and alerting, so they can be responsible for their own stuff. And they also, you saw the amount of customization that they also have in the process of this, their own repos, their own container. So there's a lot of freedom that they also have within their own space. And I quickly want to go across users. So this is something that we could have defined in that values.yaml, but we didn't. So retrospectively, we're doing that now. If I want to go ahead and create one, I'll make one for myself. And I'll make myself a platform admin so that I don't have to log in anymore as the default platform admin. And then let's make one more. Let's call this one Ryan. Ryan has the same last name as me. And let's make Ryan a team admin for that develop team. And now let's log in as this other platform user. Just click that to copy the password and open up a new browser. Just like with the other user, Keycloak is going to force us to update the password on the first login. I suppose something we could turn off, but I think it's good to keep. All right. And then if we switch back to the team view, just from the user perspective, we can see that box check there in the middle for the admin user for this specific team. Now I want to go back to that catalog that I was showing you earlier. Because we can add to it. It's extensible, and we made this very, very easy. All you need to do is give it the URL to a chart.yaml file of any Helm chart you desire. This team does use Cassandra and favors Cassandra, so I want to add that to the catalog. Paste it in. Fetches the details for us. Just make sure that box is checked, as we want to allow teams to have this in their catalog. And there's also a sneak peek at where this is going to live in the Git URL. And we have Cassandra in our catalog, along with everything in the README and all the info on how to use it. So this is all cool and all, but this is all through the UI so far. And where's the fun in that, right? We like to do things as code, and for two good reasons. One, because it's more fun, at least in my opinion, but also because code scales, right? You have a team in the enterprise realm that's trying to automate all this across different geos. We're not going to sit here and go through the UI and set this up every single time. So let's have a look at if we want to add to this catalog, just taking the GitOps approach. And in this first iteration, we're manually doing that, but you can picture this being an automated process that you build out and simplify further. We cloned that local charts repo. I want to add nats to this, and in this example, we'll just add nats server, but in reality, you'd probably want to install more than just nats server. But we'll clone that as well. And then it really is as simple as just copying it over and pushing it up. If we go back to the Git repo, refresh, we'll see my commit there. And then if we go back to the catalog, refresh, and let there be nats. And the last thing I want to go on or that I want to touch on is the portability aspect of this. Portability is something I care about a lot. So I'm very happy that there's this that you can just click on and it downloads a file that gives you all of the values, all of the YAML for everything, so you can see exactly how it's all stitched together. So you can steal this and do it differently or make it yourself. Or if you're struggling to get Argo CD to talk with your network policies and you want to see how we did it, it's there. Check out the docs. The demo repo for this is that Steal This IDP one, and then there's the core repo for APL itself. Thank you.